solve problem number 5. Find the area of the region enclosed by 4x plus y squared equals 12 and x is equal to y. So the first thing that we need to do here is to sketch the sketch the graph of the given equations for x plus y squared equals 12. And the graph of this is the parabola that opens leftward since the squared variable is y. Okay, and the graph of x is equal to y is a line that rises from left to right, and it passes through the origin. And also, we need to identify the points that we will be using later. So these are the point of intersection of these two graphs. The first intersection is at negative 6, and 2, 2. And the vertex of the parabola is 3, 0. So, and also, the parabola can be divided into two parts. The one that is above the y-axis, and let's name it as y sub 1 plus, okay, because we are talking about the function value to be positive, and the graph that is below the x-axis, and let's call it the y sub 1 minus, y sub 1 minus, since all the function values are negative. All right, now let's identify the region enclosed by these two equations. So as we could see, this is the region enclosed by the region enclosed by the two equations. All right, and let's draw the rectangular strip, the vertical rectangular strip here. So let's identify. Okay, so let's do that here. Okay, now let's identify the rectangular strip. Okay, so here we go. Here we go. And here on this side, uh, it shows that the graph or the rectangular strip uh, touches the positive y sub 1 and the negative y sub 1. And it didn't touch the y sub 2 equation or the line, right? So we're going to find a way such that it will touch the line in the graph of the parabola. So let's do it again. So let's try to put our vertical rectangular strip here. Okay, here we go. So that is our second rectangle. Okay, the vertical rectangular strip. And in this rectangular strip, it touches the y sub 2 and the y sub 1 negative. All right. Now, since these two rectangles or the representative vertical rectangles are of different in nature, okay, or characteristics, because this one touches the parabola, the y sub 1 only, while this one is the y sub 2 and the y sub 1. So we need to divide this the region into two parts. So we're going to divide this here. All right, here we go. Or let's use another color. Let's use this. Okay, let's divide this here. Okay, we need to divide this here since this is the point of intersection of the graph. And at this point, or at this boundary, now we could say that once we go to the left, now the rectangular strip touches both the y sub 2 and the y sub 1. And on the right, the rectangular strips will be touching only the y sub 1, but it touches the y sub 1 plus and the y sub 1 minus. So these are the two regions. And let's consider this as let's say that this is our A sub 1, okay, area 1, and the other side is our area 2, A sub 2, okay? So here, let's identify this is our x sub I, and of course, this is our delta x. The width is delta x, okay? And our length is equal to the higher minus the lower. So y sub 2 minus y sub 1. minus, since it's the minus y sub 1. Okay, and here, this is our delta x, and our length here is the length or the height is equal to y sub 1 plus minus y sub 1 minus, correct? Because the upper is the y sub 1 plus and the lower is the y sub 1 minus. So our area can be computed in this manner. So our area 1 is equal to, let's use the integral, okay? Directly the integral notation. So we have uh, the length, which is y sub 2 minus y sub 1, our dx from -6 to 2. Okay, that's the upper and the lower limit. And our a sub 2 is equal the integral of the upper, that's the length. So y1 plus minus y1 minus dx from, so we're going to start from what? From 2 to 3, because this is 2, right? This is 2 to 3. Okay, so from 2 to 3. Okay, so this is now our area 1 and area 2. And for us to find the area of the region enclosed by the two equations, or the total area, we have a sub 1 plus a sub 2. But then again, we need to solve for a sub 1 and a sub 2 first, all right, before we proceed to the total area. Okay, so how do we solve for a sub 1? Let's start with a sub 1. So we know that a sub 1 is equal to the area, the integral of y sub 2 minus y sub 1 dx from -6 to 2, correct? And let's substitute the values of y sub 2 and y sub 1. So 2, -6, and y sub 2 is just equal to x minus, and y sub 1, here in area 1, we know that y sub 1 is the minus. As we can see, this is the minus, the negative part. All right? Okay, so let's be specific. Okay, let's go back. This is the minus, and the minus is equal to, oh, we don't have y sub 1 minus yet. So how do we solve for y sub 1 minus? Now we know that the given equation of parabola is 4x plus y square is equal to 12. So let's solve for y in terms of x, and let's determine the y sub 1 minus and the y sub 1 plus. So this becomes y squared is equal to -4x plus 12. So y squared is equal to -4, right? Or we could just 4 and 3 minus x, okay? And let's take the square root on both sides. Okay, since we took square root on both sides, don't forget the plus or minus. Okay, so y is equal to positive or negative. What's the square root of 4? That's 2. Radical 3 minus x. So our y sub 1 plus is equal to the positive 2 times 3 square root of 3 minus x. And the y sub 1 minus is equal to -2 times 3 minus x. Okay, so let's specify this. All right, let's put asterisks here. So let's say double asterisks. So here, we can now continue solving here. So what is y sub 1 minus? Y sub 1 minus is this, so -2, 3 minus x. All right, I hope you got what I mean here. And let's simplify. So 2, -6, let's simplify. X minus or plus 2, 3 minus x dx. Okay, and here we can distribute the integral notation, since this one is easier to integrate, while the next term is quite hard to integrate. So we have the integral of x dx from negative 6 to 2 plus 2, the integral of 3, the square root 3 minus x dx from negative 6 to 2. So we have, this is area 1, areas of 1. So areas of 1 is divided into 2 terms. So let's continue solving areas of 1. Areas of 1 is equal to, okay, let's copy, x dx negative, oh, sorry. All right, so let me just erase this. So that's 6 dx negative 6 2, okay? And the other one is, we have 2 square root of 3 minus x dx negative 6 2. So here, this is just equal to x squared over 2 to be evaluated from 2 to negative 6, right? And this is equal to 2 minus 18. This is equal to negative 16. And let's integrate the second term here. So the second term, we can solve this. We can use the Latin here. We let u is equal to 3 minus x. So we're using integration by substitution. So du is equal to negative dx, and negative du is equal to dx, right? So let's integrate this. So 2, negative 6 to 2, and u raised to 1 half u, because 3 minus x is u, and in exponential form, okay, this is the square root is just equal to raised to 1 half, and dx is equal to negative du. Why did we use negative du or du? Because we're now using u instead of x. So let's integrate this, okay? So this becomes, this becomes negative 2 because of this, all right? So this becomes negative 6 to u raised to 1 half du, okay? Okay, so this becomes negative 2, and let's integrate. So what's the integral of u raised to 1 half? U raised to 1 half is equal to u raised to 3 halves over 3 halves, and to be evaluated from negative 6 to 2, correct? And let's simplify this, okay? So let's simplify the second term. So this becomes negative 2 times 2/3 times, what's the value of u? U is equal to 3 minus x raised to, sorry, this is 3 halves. 3 halves from negative 6 to 2. So let's simplify this. This becomes negative 4/3 3 minus x raised to 3 halves from 2 to, or negative 6 to 2. Okay, since we don't have space, let's use another space. Let's simplify the second term. So we have the second term is equal to, okay, so let's copy 2, 3 minus x dx, negative 6 and 2 is equal to, what's that? We have negative 4/3, negative 4/3 times 3 minus x raised to 3 halves, and to be evaluated from negative 6 to 2. And let's simplify negative 4/3 times, okay, let's substitute 2. So this becomes 1, and 1 raised to 3 halves is 1, minus negative 6. 3 minus negative 6, that's 9. Square root of 9 is 3. And cube of 3 is 27. Okay, here we go. So this becomes negative 4 over 3 times negative 26. And this becomes what's this, 104 over 3. So 104 over 3 is equal to the second term of the integral of a sub 1. So we knew that a sub 1 is equal to, let's copy, this is negative 16, right? Negative 16 plus our answer here is 104 over 3. So this becomes, oh, negative 16. So this is 48, negative 48 plus 104 over 3 is equal to what? So this is 6, 956 over 3. So is it correct? Oh, sorry. 10, 56 over 3. Yeah, that's right, 56 over 3. So that's a sub 1. This is just our a sub 1. Okay, let's enclose this by a red. A sub 1. Okay, now we just got a sub 1 here. So what we need is to find the value of a sub 2 here, right? So a sub 2 is just this, y sub 1 plus minus y sub 1 minus from 2 to 3. Okay, so let's go to a sub 2. So to get the area, the second area, this is equal to the integral of y sub 1 plus minus y sub 1 minus dx from 2 to 3. All right, so you may check that later. You can go back to the previous slide or space for solution to check if this is correct, but I'm sure it is. So this becomes 3, 2, and we know that y sub 1 is the positive part. So that's 2 square root of 3 minus x minus the negative. Okay, so negative 2 square root of 3 minus x dx, right? Okay, so let's simplify. So the integral of, so this is equal to 4 square root of 3 minus x dx, and this is from 2 to 3. Okay, and this can be simplified into square root of 3 minus x dx from 2 to 3. Okay, so again, this is also similar to the one that we had a while ago. So we're going to let u, okay, let u is equal to 3 minus x, and du is equal to negative dx. Therefore, negative du is equal to dx, right? Okay, so now let's continue here. So we have 4 integral of u raised to 1/2 times negative du from 2 to 3. Okay, what happened? Why it became negative du? Because dx is equal to negative du. And since we express the given expression into u, therefore, the with respect to x should be with respect to u as well. So this becomes negative 4, the integral of u raised to 1/2 du from 2 to 3. Okay, so let's integrate. So negative 4, what's the integral of u raised to 1/2? That's u raised to 3 halves over 3 halves to be evaluated from 2 to 3. So here this becomes negative 8 over 3. Oops. Okay, and all right, so u raised to, oh, sorry. Now we can substitute the value of u here, all right? So the value of u is 3 minus x, so 3 minus x raised to 3 halves to be evaluated from 3 to, correct? Okay, so let's try evaluating this. So negative 8 thirds, okay. So if x is equal to 3, this becomes 0. So 0 minus, okay, minus, and let's substitute 2. So 3 minus 2 is 1, and 1 raised to 3 halves is equal to 1. So, and this becomes 8 over 3, right? Okay, so we know that a sub 2 is equal to, okay, let's put red, a sub 2 is equal to a thirds. So in this case, we can now say the total area is equal to a sub 1 plus, oh, sorry, plus a sub 2. A sub 1 is equal to 56 over 3, and this is 8 over 3. Let's double check that. 8 thirds and a sub 1 is 56 over 3. That's correct. Okay, and so let's add. So this one is equal to 64 over 3 is our total, is our total area. Total area, square units. Okay, that's the total area if we're going to consider the vertical strips, correct? All right, now let's consider, okay, now let's go back to the equation, I mean to the graph. Okay, now look at this. Now what if, okay, what if okay, now what if the graphs look like this? So, okay, let's just sketch the graph, something like that. And the line is here. Okay, these are the points of intersection. Now, what if we make instead of putting or assigning or constructing vertical line strips, why don't we just construct a horizontal, okay, a horizontal, oh, sorry, a horizontal rectangular strips instead. Yeah, that's it. And let's try constructing more. And let's see if we could have, if we could, here we go. Okay, if we could find a vertical line strip wherein it has the same behavior with the other vertical strips, horizontal strips. Now in this case, if we're going to do it horizontally, then we could say, or we will observe that it will always touch the two graphs, the y is equal to x and the parabola in different areas of the region, right? So therefore, we could use these horizontal rectangular strips to solve for the area of this region at once instead of using the vertical rectangular strips. So let's try using the horizontal strips. And let's supply the values. So let's use this. Let's use this part here. Okay, here. So this is our change of y. Why? Because we are talking about horizontal. Okay, we're talking about the y values here, the change of y. And this becomes the x, right? So we are now subtracting the x values here. So let's say this is our x sub 1 and this is our x sub 2, okay? Since this is our rightmost part, so for us to get the height or the length of this horizontal strip, this becomes x sub 1 minus x sub 2. Understood? So therefore, for us to get the area, okay, the area of the region, A sub I, okay, so we have the length is x sub 1 minus x sub 2 times change of y or delta y, right? So if we're going to express this in the form of Riemann sums, this becomes the limit of the summation of x sub 1 minus x sub 2 times delta y as I starts from 1 until n, and n approaches infinity. Okay, so let's convert this to the integral notation. So this becomes x sub 1 minus x sub 2 delta, change of x, with respect to x from a to b. Okay, so here we go. Now let's identify the upper and lower limits first. Now we know that the point of intersections are negative 6, and 2, 2, right? So instead of using x here, we will be using y, since with respect, oh sorry, it should be y, with respect to y. So since the points are just equal, the coordinates are just equal in one point, so we are getting the integral from negative 6 to 2 still, x sub 1 minus x sub 2 dy. Okay, now the question is, what is our x sub 1 and what is our x sub 2? Okay, now our x sub 1, okay, our x sub 1, okay, let's do that here, the other side. X sub 1, our x sub 1 is our parabola, and x sub 2 is our line. Okay, now the parabola has an equation 4x plus y squared is equal to 12. So we can solve for x. Let's say this is x of 1. So 4x of 1 is equal to 12 minus y squared. And x of 1 is equal to 3 minus y squared over 4. And for the line, okay, this x sub 2 is equal to y. Simple, right? So we can now substitute these values of x of 1 and x of 2 in the given integral notation here. So let's copy. So our integral now becomes the integral of x sub 1 minus x sub 2 dy from negative 6 to 2 is equal to, okay, the integral of negative 6 to 2, our x of 1 is this. So 3 minus y squared over 4, all right, minus our x of 2 is just y, okay? And of course, dy. Okay, so since we lack space, let's use this, use the other part or other side. So that's the integral of, what's that again? Let's simplify. That's 3 minus y. Okay, 3 minus y squared over 4 dy from negative 6 to 2. Am I correct? Let's check. Okay, here we go. We're correct. Okay, so let's solve this. So we have, let's integrate. So 3y minus y squared over 2 minus y cubed over, what's that, 12 from negative 6 to 2. Correct? And we should be getting the same answer. The answer was 64 over 3. So let's substitute 2. So we have 6 minus 2 minus, this becomes 8 over 12 minus, this becomes negative 18, this becomes negative 36, negative 18, am I correct? Yeah, 36 over 2 is 18 minus, this is 6, so this becomes, so 6 times 36 over 12, this is minus. Okay, let's simplify. Let's simplify here. This becomes 4 2/3, and this becomes cancel 2, and this becomes 18. Am I right? Oh, let's check. So 2, 36, 18. Correct. So let's solve it now. So this becomes 6 minus 4 minus 2/3 minus, okay, let's check. Oh, this becomes positive, this becomes negative. Okay, let's check. Oh, let's check our equation. X sub 1, let's check here. X sub 1 is our parabola, and X sub 2 is the y. Oh, I think yeah, we're correct. 3 minus y, right? X sub 2. Okay, that's correct. Okay, let's just double check. Okay, let's double check. So this becomes what? Uh-huh. This is positive, right? Positive, so I can cancel this out. So this becomes negative 18. And this is what? This is equal to 12 minus, this is 10 over 3 plus 18. See, 10 plus 54 over 3 is equal to 64 over 3 square units. Okay, so it means we got the same answer with our previous solution, 64 over 3 and 64 over 3, which means that whatever type of method you'll use, either horizontal or vertical or rectangular strips, as long as you did it properly and correctly, then you'll get the same answer. But again, you can choose the easier way to simplify or to get the area of the area to get the area of the region enclosed by the given equations, okay, or the curves. So for me, the easier way to do that is using the horizontal strip instead of the vertical one, because in vertical you need to divide it into two parts, into two partitions, like this. Okay, so let's just digest, okay, and analyze. So here you need to divide it into two partitions, which makes the solutions longer, okay, longer, and you are prone to errors. And I got a lot of errors. And here, when you use the horizontal, then it becomes simpler because you will only use one area because there's only one partition, okay? Or you can integrate it directly. All right, so that's it. I hope you understood everything. And post your comments if you have questions.